Question number 1. A simple pendulum spins through an angle 1 degree in 1 second. The same pendulum is made to spin through an angle 2 degrees. The time taken to spin through the angle of 2 degrees is. Like we know that the equation of a simple pendulum is T equals 2 pi root L over G. Then the motion of simple pendulum, the period of simple pendulum, T is depending on length and gravitational acceleration. Therefore, it is not depending with angle. Therefore, time is same for both pendulums. Then answer 3 is correct one. It also takes 1 second to oscillate. Third answer is answer for the question number 1. Question number 2. Which of the following sketches best represent the relation between the acceleration of a body executing simple harmonic motion and displacement of the body from its equilibrium position? For a simple harmonic motion, we know that acceleration of simple harmonic motion is minus omega squared x over y. We are using x for the simple harmonic motion in x-axis and y for the simple harmonic motion in y-axis. Therefore, x over y it is representing displacement. Then acceleration equals minus omega squared x. It is the common equation for the acceleration of simple harmonic motion. Now they have given a for the y-axis, x for the x-axis. Then y, it is the shape y equals minus mx. We have to select y equals minus mx shape graph. Minus mx means there is a minus gradient. Therefore, this angle should be an obtuse angle. This angle between graph and cross direction of x-axis is an obtuse angle. We know that it is a minus gradient. And there is no intersection. There is no intercept for the graph, C value. Therefore, it should be past the origin. Intercept is 0. Then answer 4 is the correct answer for question number 3. Question number 2. Third question. A certain mass performs simple harmonic motion about a point O with amplitude A and period T. They have given amplitude simple A. Its displacement from O at time T equals T over 4 after passing through the origin is OE. It is easy to decide. We know that we can consider it is a motion like this. At this point, time is 0. After getting 1/4 of period, it should move to this place, T over 4 times. Again, half of period, it should be at this place. 3 T over 4, 3/4 of period, it should be at this end. Again, when completing full period, it should be at middle point. Now they have given the displacement from O at time T equals T over 4. When time T over 4, it should be at the oscillating end. Oscillating end means its displacement should be amplitude. Then answer 4 for the question number 3. Question number 4. An elastic string with a spin constant K is cut into 2 parts of equal length, the spin constant of one part is. We have to remember the theory. Spin or elastic with spin constant K. If it cut into n parts, then spin constant for one part is Kn, K times n. Now they have given the spin is cut into two equal parts. Therefore, K into 2. It means 2K is the spin constant for one part. Then answer 5 is correct for the question number 4. You have to remember it as a theory. Then question number 5. Which one of the following energy displacement graphs best represent the variation of kinetic energy K, potential energy V, and total energy T with the displacement of a particle performing simple harmonic motion? Now I will consider this diagram again. Simple pendulum. We know that for the simple harmonic motion, the maximum velocity could be observed at this point, middle point. Maximum velocity, when the object has the maximum velocity, its kinetic energy should be maximum. Therefore, kinetic energy graph is like this. Kinetic energy. And there is an energy conversion for the simple harmonic motion. At this stage, kinetic energy maximum, potential energy 0. When moving to this point, end point, oscillating end, kinetic energy should be 0, velocity 0, and potential energy should be maximum. Therefore, potential energy graph should be like this. It is potential energy. And we know that according to conservation of energy, total energy of the system should be conserved. Therefore, total energy graph is like this. This is the total energy. Now, kinetic energy, potential energy, total energy. Second answer is correct answer for question number 5. Then question number 6. The graph shows the variation of displacement y of an object with time t. Which one of the following graphs represent the variation of kinetic energy of this object with time? Right, now we have to identify the initial displacement is the maximum value. It means initially the object is at an oscillating end. And we know that kinetic energy at oscillating end should be 0. Then kinetic energy should be starting from 0. And when it returns to the oscillating center, displacement 0 means oscillating center of the object. When it returns to the oscillating center, kinetic energy should be maximum. Like this. Then it is moving in opposite direction to the oscillating end. When it is moving oscillating end in opposite direction, kinetic energy should be minimum, 0. And again, it is moving to the oscillating center. Kinetic energy should be maximum. Kinetic energy is a scalar. We have to consider only plus direction. then answer is like this. We can get third answer is the correct answer for question number 6. Question number 7. The following graph shows how a certain quantity x, y and z vary with the displacement d of the particle under the simple harmonic motion. Quantity x, y and z. In the first graph, they have given quantity x is constant with displacement. Therefore, we know that quantity x should be total energy. Total energy is constant. For the second part, they have given a graph like this. Displacement with y quantity. It is a displacement time graph. I will consider displacement time graph, xt graph for the simple harmonic motion. At the initial point, displacement is maximum for this graph, and displacement becomes 0, again minus maximum, 0 plus maximum, again 0 minus maximum. This graph is like this, but they have interchanged physical quantities. Therefore, displacement is in this axis, it means x, this should be time, then y is representing time. Last one, we know that there is only one straight line graph relative to simple harmonic motion. It is the graph representing this acceleration minus omega squared x, y equals minus mx type graph. Therefore, this is the displacement. It is given in the question. Z should be acceleration. Then total energy, time and acceleration. But there is no an answer with corresponding physical quantities. Total energy, time are given, but there is no an acceleration in the answers. Total energy, time. We know that according to F equals ma, acceleration is directly proportional to force. Therefore, we can consider acceleration of force is the physical quantity present in Z. Then we can get total energy, time and force is the force are the physical quantities. Answer 2 is question. The answer for question number 7. The period of an object performing a simple harmonic motion depends on amplitude of oscillation, b, the speed of the object at equilibrium point, the initial position of the object. Of the above statements, we have to select correct statement. I will explain it by using simple pendulum. Because of we know the equation for period of simple pendulum. When considering simple pendulum, period is 2 pi root L over G. But for the simple pendulum, amplitude is this length. It is not in the equation for the period. Therefore, it is not depending amplitude. A is incorrect. B, speed of object at the equilibrium point, it also not in the equation. Therefore, period is not depending with velocity at the equilibrium point. It means maximum velocity of the simple harmonic motion. See the initial position, it also not in the equation. Therefore, A, B, C are false. All A, B, C are false. Answer 5 for the question number 8. Then question number 9. For an object undergoing simple harmonic motion, they have given statements. We have to select correct statement. First statement, the magnitude of the acceleration is maximum when the displacement is maximum. Oh, we know that acceleration is minus omega squared x. When displacement is maximum, it means displacement equals amplitude, the acceleration should be maximum. Then first statement is correct. They have given the magnitude of acceleration is maximum when the displacement is maximum. Then answer is 1 for the question number 9. Then 10. The variation of speed u with time of a simple harmonic motion, simple harmonic oscillator, is shown in the figure. The variation of its velocity with time best represented by. They have given speed. It is the scalar. Scalar is like this. We have to consider only first direction. Speed is the scalar. Now we have to get the velocity. Velocity is a vector. Then velocity should be start from maximum, and at this place it should be in minus maximum. Then we have to draw the graph like this. Again 0 plus maximum, 0 minus maximum, again 0. They have given only this part. Then we have to stop the graph from this part. Then answer is 1 for the question number 10.